If you wrote it out, let's be finished. It was a little bit quirky, but overall, I think it probably all right. All right, so here we go. Today we're talking about scatter plots, and we want to be able to draw scatter plots, which I know you all can do perfectly fine, and maybe answer a few questions about them. A scatter plot is a graph that shows the relationship. A graph that shows the relationship between two sets of data. Between two sets of data. And there are three different types of relationships. So positive, negative, or no relationship. And so what we're doing is we're going to be graphing things on the XY coordinate plane. So I know you know how to do that. And you're going to be graphing the two little inputs and outputs, and they're going to create a little pattern like that. So maybe those little dots all fall, and you can see how they're kind of going, would you say this is uphill or downhill? Yeah, they're going uphill. So this is a positive relationship. And maybe the relationship goes downhill a little bit like that. That would be a negative relationship. As the X is getting bigger, the Y values are getting smaller. All right? And then, of course, the last one we could have is no relationship at all, in which case it just looks like a big bunch of dots kind of random. All right? There's no linear, like following a pattern. All right. Let's look down here at drawing some scatter plots. All right, number 4. We want to draw the scatter plot and identify the relationship. Ladies, when you look at the information that we have here on number 4, they're giving us hours and they're giving us the grade. And so this is the number of hours a student studied for a test and their grade. And so we're going to create a little relationship here, and usually we put time on the x-axis. So we're going to put hours on the x-axis, the horizontal axis, and we're going to put their grade earned on the y-axis. And I'm going to go ahead. It looks like we're going from 1 up to 8 or so, so I'm just going to count by ones here. So on the hours side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will do. And then for the grade, it looks like we're going, well, we'll just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got about, okay, well, I think we can probably then just count by 10s. That'll be fine. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's good enough. All right, once you've got your graph filled out, once you've got it labeled, we can start plotting points. So go ahead and plot 3 hours and a grade of 80. 3 hours studying, they got an 80 on their test. So you should have a dot like that. 5 hours studying, and they got a 90 on their test. 2 hours studying, and they got a 45. All right, so keep going. right, so hopefully you've got those just about plotted on your little scatter plot there. Would you say that this data is going uphill or is it going downhill? It's going uphill. We always read a graph from the left side to the right. So as we're moving to the right, it is going uphill, and that's really important. So is this a positive or a negative? It's a positive relationship. They also will, you'll see the word positive correlation. It is a positive correlation. Write this down. Positive because as the hours increase, the grade increases. As the number of hours you study goes up, the grade also goes up. All right. As the hours increase, the grade increases. All right, let's look at number 5. Number 5, the number of hours a person spent in the mall, and the amount of money they spent. Ooh, yes. All right, so once again, I'm going to put hours that you spent in the mall on the x-axis, and then dollars spent on the y-axis. And let's see, it looks like I'm just going to count 1, 2, 4, 6, 8, 10. That'll do. So I'm really counting by ones every time. All right, and then dollars spent, I think I can just count by tens again. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. I got to go up to 120 because I have a 115 there. All right, and once again, let's go ahead and plot the data. So at 1 hour, we spent $40. That's pretty standard. Ooh, 8 hours, you spent $25. They were in the mall a long time. They must have just had lunch. They needed some food. 8 hours at the mall, man. I wonder if they were doing their steps. $7.30. All right, $5, $70. $9.95. $2.40. $1.15. They must have bought a pair of shoes. 5 hours, only $15. They went to the movies. All right. Well, what do you think? Do you think this is a positive, negative, or no correlation? No correlation. There is no correlation here. There is none. No relationship there. Everything is scattered. It's just a big blob. There's no pattern. Okay, so pretty good. All right, any questions on those? All right, last one, well, not last one, but number 6, the last one we're going to actually graph. Number 6, the percent of households in the city with a landline telephone. Oh, interesting. Okay, so we're starting, we've got years we're going to put on the bottom axis. And then we've got percent of homes with a landline. Percent with landline. Does anyone in here have a landline? What's that? No. No. Like you got a phone attached to the wall?
I have one, but it's not hooked up. It's my dead grandpa's. Okay.
All right. Yeah, that's pretty funny. All right. Okay. So 2000. I'm just going to start. We're going from 2000 all the way to 2016. I need to count by 2 years. So this is going to be, I'm going to do 02, 04, 06, 08. This is 2010, 2012, 2014, 16, 18, 2020, and 2022. All right. All right. Those are counting by twos. And then on landlines, I'm going to just count again. 02, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Why are there? Yeah. Okay, I'm going to count by tens again here. So 10, 20, 40, 60, 80, 100, 120. Okay. All right. All right, we got our graph. Start. The nice thing is on Delta Math, you don't have to put the labels on. They're already there. So, always a good thing. All right, I'm going to go ahead. In 2000, which is right here, we had 84% have a landline. I did have a landline in the year 2000. 2002, 80%. 2004, 73%. 2006, 68. 08, 65. 2010. Hi. What do you need? Linux is in the back.
Linux, is it your birthday today? Ooh, happy late birthday. I mean early.
Thank you. All right, let's see. This is 2010, 55. 2012, 51. 2014, 47. And 2016, 42. Wow, positive or negative? Negative. That has a negative relationship. And it is going downhill. We would say it's negative because as the X, or not X, we're not using X, we're using years. As the year increases, the percent decreases. You want to write that down, that'll help with your Delta Math today. As the year increases, so our years are always increasing. We always talk about the x-axis increasing, and then the y either goes up or down. So our y values are going down. All right, questions on those? All right, so move down to the bottom here. We want to answer a couple of questions. They're really easy, yeah. A company's stock price since it launched in 2006 is shown below. Ladies, what is the approximate stock price in 2015? Yeah, so 2015 is right here, and it looks like it's like 22 or 23. Yeah, and what does that mean? Is it $22? Dollars per share. So we want to use that. Dollars per share. So you really want to read what it is talking about on your graph there. In what year or years was the stock price $35 per share? Let's see. So 35 is right here. And so we want to look. $35 per share would be on the y-axis, and yeah, you can see it in the year 20, well, it's not the year 10, but it'd be 2010, yeah? 2010 and 2012, very good. All right, and that's just where we see the dots here and here, and then they fall on the year down here, so we can match those up. What's the relationship? Negative. Very good. Okay, Olivia bought a used car in April. The graph shows the odometer reading. What's the odometer? How many miles your car has driven? Yeah. And you'll notice that the odometer reading is in thousands of miles. So 4 means what? 4,000. And 12 means 12,000. So you got to keep that straight. Reading each month after she bought the car. So what's right here? What's this point at 0? 3,000, 2,500, maybe 3,000. But like, what does that mean? At the very start, the very first, she got the car, she had it 0 months, that was the first day. So right here, this dot at 0 months, that is when she first acquired the car. And that's important to understand. So here, she just got her car. Always a good thing to understand when you're reading a graph. When time is 0, that means you just got it. All right, it just started. So she got it, it had like 3,000 miles on it. Approximately how many miles? Approximately how many miles were on the car when she bought it? When she bought it, how many miles? 3,000. Yeah, 3,000. That point right there is about 3,000. Approximately how many miles were on the car in July? Olivia bought a used car in April.
10,000.
So this is really important. She bought the used car in April. So this is at 0. What month is it? So, Piper, she bought the car in April. So right here, she just got her car. What month is it? It's April. It's April when she bought her car. So that's April. The next month would be May, and then June, and then July would be right there. So approximately how many miles are in July? Like 7,000, yeah, 7,000 miles. So you really have to make sure you're reading a problem carefully about 7,000 miles. That's July right there. So this dot right here is representing July. Okay? Because she bought her car in April. So this is when she bought her car. And what month did the car reach 14,000 miles? Yeah, well, here's the 14,000 miles right there. And we want to know what month is that. Well, let's see, we're July, August, September, October, November, December, January. Yep. January. All right. All right, do you guys have questions for me? Keep your notes handy.